So this is where we start discussing the summative. We go to LMS, we open the task, which is the summative for criterion D, and here we see the instructions about the summative. So currently the deadline is Wednesday, but I may change it to Thursday. This is the word file for the summative which you have to download and attempt the summative on. If any one of you have any issues with this, you can use a Google Doc link which I've created, but make sure that you work on your own Google Doc and not the same doc that anyone else is working on. And the image to upload on Desmos is also there. So you can download it and attach it in your Word document. So I'm gonna open a Word document as a sample to show it to you. And it's better not to try to take a snapshot of this image, because then you guys might have different like images of different sizes, because your word may be zoomed into your liking and you might get different answers. So in order to ensure uniformity of answers, please download the image from LMS and then upload it onto Google Doc or Word. The same way that I have downloaded this image, and it's very easy to copy paste this or insert this in a Word document. So I am going to try and solve a couple of questions for the summative so that you have an understanding of what to do. This introduction is not really needed, just jump into the questions as follows. Make sure when you upload your image on Desmos, this red dot should fall on the origin, which is the point 0, 0. I'm doing this so that all of you get more or less the same answers. So all the instructions are given of how to upload the image on Desmos. Do not change the size of the image, meaning do not stretch or compress it from any size. Just let it be of the same size. Let it be of the same size and only change its position, like drag it around such that your origin is placed on the red dot. The video is also attached. You should know that the y-axis represents the height of the building. And once you've pasted your image on Desmos, paste a screenshot in the Word document by pressing enter and creating space, so that I know that you have pasted your image correctly and I can see what are the answers that you're going to get. And this is how you actually do it. If you don't have time to watch the video, this is how you do it. Only press the center circle to actually just drag the image without changing its size. Do not press these right, left, up, down circles. Okay, so this is how you are supposed to put your image correctly, where the origin or the 0, 0 point falls on the red dot. And this is how your image should look like. You have to take a screenshot of this screen that you see and paste it on Word so that I know that you've done this part correctly, and you will get your 2 marks. Also, for this question, we will be looking at the outer boundary of the building as we model the parabola, because we know that this image has some thickness. So you might think that whether I have to look at the lower boundary or the inner boundary or the outer boundary. So please look at this outer boundary while you actually solve this question and give your answers, so that we can have some uniformity in all of your answers. So now let's look at how to do the questions for model A. By looking at your x-intercepts from Desmos, write a quadratic equation in the intercept form. Those who know the intercept form, they would know that P and Q represent the x-intercepts, which is a point where your graph cuts the x-axis, and you need to change the signs of P and Q before inserting them in the equation. So if we see our image, we can clearly see that the x-intercepts lie at the point which is 4, and this is the point minus 1.6. We need to look at the outer boundary. So just write 4 and minus 1.6 in your equation, but you have to change the signs. So it's going to be y equals to a x plus, sorry, x minus 4. It was a plus 4, so you changed the sign, and it was a minus 1.6, so you write it as x plus 1.6. And this is your answer for step number 1. That's it. Select any one point that lies on your curve and substitute the coordinates of it in your equation found in step 1 to find A. If you see your equation which is found in step 1, you see three symbols x, y, and A, which means that if you know the values of x and y, you can find the value of A. So x and y represent a point which lies on the curve that you're trying to model, meaning on the outer edge of the building. So that point should lie on the outer edge of the building. I would advise that you select a point that lies on a grid value so that you don't estimate the decimals of that point. So if I can actually see, and if I go to the point 3 comma 4, I can see that it almost lies exactly on the outer curve of the building. So I can choose that point really easily. So the point 3 comma 4 is the point that I am going to choose, and I would plug in 3 in place of x and 4 in place of y, which are going to be my coordinates in this case. And after plugging them in, I would find the value of A. So this is how it goes. So the point that I'm going to select is 3 comma 4, plug in 3 in place of x, plug in 4 in place of y, and then find the value of A. So y equals to A, x minus 4 in one bracket, x plus 1.6 in the other bracket. Now do the substitutions. 4 equals to A, 3 minus 4, and 3 plus 1.6. So in place of y, I've plugged in a 4. In place of x, I've plugged in a 3. So doing this on my calculator, 3 minus 4 is minus 1. So that's a minus A. And you multiply that by 3 plus 1.6, which is 4.6. 4.6 multiplied by minus A is minus 4.6A. A is going to be equal to 4 divided by minus 4.6. And getting the answer on my calculator, I would get a decimal answer for A, which is going to be it's going to be negative 0.87 after rounding it off. So that's it, you found A. And now you practically know almost everything from your equation in the intercept form, which is going to be y equals to minus 0.87, opening the bracket x minus 4, and opening another bracket x plus 1.6. So this is your answer for step number 2. Now convert your equation in the standard form by expanding the brackets and simplifying. In class, we have already done the topic of how to convert an equation in the intercept form into the standard form by opening the brackets and simplifying. So this is something that you have to do with your answer that's over here. So I'm pretty sure all of you can do that. Similarly, now coming to model B, by looking at your turning point from Desmos, write down the quadratic model in the vertex form. If you know the vertex form, you would know that h represents the x coordinate of the vertex with the sign reversed, and k represents the y coordinate of the vertex. And we know that the vertex is the turning point, which is the maximum or the minimum value. Can I spot the maximum value over here? So I have to zoom into this and see the topmost value over here. So I think this is really close to 1.25 as an x coordinate, or maybe 1.3 as an x coordinate, and the y coordinate is really close to something like 5.45 or 5.46 or something like that. So just choose any value that you seem is accurate enough and plug it in place of h and k. For h you would need to change the sign, and for k do not change the sign. For step number 5, select the same point that you selected in step 2 and substitute it in the equation above. Meaning, in place of x and y, put 3, 4 respectively and find A. And then expand your equation to convert it into the standard form. You already know how to expand your equation from the vertex form to the standard form by opening the brackets and stuff. We have already done that in class, and you would get your answer for step number 6. For part C, which is like for model C, which is going to be modeling through Desmos, use Desmos to find a quadratic model and make sure your final answer is in the standard form. Now, I would advise that you solve this question through the vertex form, because the vertex form actually teaches us really easily the upshift, the downshift, the left shift, the right shift, and getting thinner or wider. So that's really easy to tweak my curve around and make it fit the building, the shape of the building really easily. So I'm gonna do that. Let's see that happen. So will we go to Desmos, type our general form of the equation in the vertex form, which is y equals to a, open a bracket, x minus h whole square plus k. So I need to add the sliders for all of these letters so that I can tweak them. You know that A deals with getting thinner or wider or opening up or down. H deals with moving left or right. K deals with moving up or down. Okay, so let's see this. So I first change A to a negative value so that my curve opens downwards. I'll change the width of it in a bit. Let's move the curve up to how high we actually want it, and let's move it to the right. So now just tweak this a bit, like zoom into this, try to change the slider really slowly so that you can get the most accurate modeling of your building as possible. Your answers can vary, they should not be exactly the same, and you can even move in decimals and really small steps by just clicking on uh, H, K, or A and entering any value of your choice. Okay, so I've tried to make it look good, but I can still see that it's sort of not that accurate, but I think this is the best that I could come up with. Well, I can click on the value of K, which is 5.4, and enter my own decimal value as long as it is going to be as accurate as possible. So I've gone into two decimal values for K, so I'm allowed to do that. Once you select your values for H, K, and A, take a screenshot of this, paste it on your Word file so that I know that you've done this part on your own, and then convert the vertex form into the standard form by just opening the brackets as you did for step number 6. And that's it. So now moving on to part number 2. Use your equation from model A that you got from step number 3, that is written over here in step number 3, the equation in the standard form, to predict the height of the building when you move 3 meters to the right of the origin, meaning when the x coordinate is 3, find y. Y represents the height of the building. So when your x coordinate is 3, when the value of x in the equation is 3, find y. As we know that the y value represents the height of the building. So you don't need to go to Desmos and actually see what's happening. Simply plug in x equals to 3 to your answer in part number 3. So if I guess my answer in part number 3 or question number 3 as y equals to minus 0.87 x squared plus 5x minus 10, I'm just making up values. I just need to plug in x equals to 3 and find the value of y. That's it. So I only need to show the math over here. I do not need to open Desmos and just read off the value, like the height of the building when x is 3. That's going to be in the next step, in step number 2 that follows. Okay, so this is where Desmos is to be used. Find the actual height of the building when you move 3 meters to the right, meaning when x is 3, if you go on your uh, building over here, when x is 3, what's the height that you see? It's actually 4 or very close to 4. Okay, so just write that the height is 4. The y value is 4 when x is 3. That's it. And now you need to find out the difference between the value that you got over here and the value that you got previously by doing the math, because this is actually a method of checking accuracy. The actual height compared with the height that your model, your equation gave to you, are they really close? Like, what's the difference in between them? So you subtract your answer from step 1 and step 2. That is going to be your answer for step 3 by subtracting your predicted height with the actual height. Predicted height was the answer for step 1, actual height is the answer for step 2. You subtract them, that's it. And you will get your residual, which is known as your error, your difference between the two answers. So these are actually the same steps that you will do for model B and model C, and you will come up with their residual values as well. Moving 0.6 meters to the left is simply means when x is minus 0.6, and you will find the residuals for these also. And in the end, when you actually have to decide which model is the best, obviously the model with the smallest residual, or the residual value which is closest to 0, that is going to be your best model, because the error in that model is going to be the least. Comment on the accuracy of your models. I would advise that you decide your decimal places, your decimal values for all the symbols which are A, B, C, P, Q, H, K. Uh, so that they can be compared. Like, don't go too many decimal places for one of these values and no decimal places for any one of these symbols. It can be possible, but when you have very long decimal answers, just try to choose an accuracy level like 2 decimal places or something like that. So when you decide your best model, just attempt this last section by using your best model and answer the questions really generally. Okay. You can also look at point number 5, which is comment on how the height of the building is dependent on the position of the origin. Obviously, I made you guys have the origin fixed. I forced this on you. If you had the choice to select your own origin, you could have had different answers, obviously, for the height. So that's it.